Venezuela may be the first nation to lose all its glaciers. Scientists say the South American nation's last glacier is now just an ice field.
A melting glacier is moving the Italian-Swiss border near one of the world's largest ski resorts.
Scientists say melting Antarctic iceberg poses major sea level threat. Warm weather melts Italian alpine glaciers despite abundant spring snowfall.
Rescue effort at ice cave in Iceland ends after police say no one is missing. 1 dead, 2 missing after ice cave collapse in Iceland.
Austria is likely to be largely ice-free within 45 years as glaciers recede quickly.
Glaciers, majestic, ancient, and irreplaceable. They hold Earth's history frozen in time, but today they're melting faster than ever. What's causing this? How does it affect our planet, and what can we do about it? Let's dive into the story of the melting giants. Glaciers form over thousands of years as snow compresses into dense ice. Covering about 10% of Earth's land area, they store around 69% of the planet's fresh water. But they're more than frozen reservoirs. They're critical regulators of Earth's climate. From the towering ice sheets of Antarctica and Greenland to mountain glaciers in the Himalayas and Andes, these ice masses help cool the planet by reflecting sunlight back into space. But as they retreat, this natural cooling system weakens. Since the mid-20th century, glaciers worldwide have been shrinking at unprecedented rates. In Greenland alone, ice loss has accelerated to 280 billion tons per year. That's nearly the weight of 1 billion Empire State Buildings, gone annually. The Arctic region is heating up to 3 times faster than the global average, causing even more dramatic melting. Scientists warn that if current trends continue, glaciers in Europe and many other regions could disappear by the end of this century. The consequences of glacier melt are far-reaching. One major impact is sea level rise. Since 1900, melting ice and thermal expansion have raised global sea levels by over 20 centimeters, threatening millions living in low-lying areas. Coastal communities are already feeling the effects, from disappearing land to increased flooding. By 2100, scientists predict sea levels could rise by up to 2 meters, drastically altering coastlines worldwide. But it's not just the oceans. Glaciers also feed rivers that supply drinking water and irrigation for over 2 billion people. As they shrink, these communities face water shortages and crop failures. Glacier retreat doesn't just affect water and sea levels, it also impacts Earth's crust. When massive ice sheets melt, they relieve pressure on the land below, a process called isostatic rebound. This can trigger earthquakes and volcanic eruptions in some regions. Melting glaciers can trigger volcanic eruptions through a process known as glacial unloading. When massive ice sheets melt, the pressure they exert on Earth's crust decreases. This reduction in pressure can destabilize magma chambers beneath the surface, making it easier for magma to rise and potentially causing volcanic activity. In Iceland, volcanoes like Grímsvötn have shown increased activity linked to glacier retreat after the last ice age. Studies indicate that similar processes might occur in other regions like Alaska, where glacier melting is accelerating due to climate change. Greenland's retreating glaciers are also unveiling treasures, ancient rocks, potential mineral deposits, and ecosystems hidden for millennia. But while this offers new opportunities, it raises ethical and environmental concerns about exploitation. In Greenland, retreating ice has unveiled rocks that date back 3.7 billion years, among the oldest on Earth. These rocks are like pages of a book, revealing the early chapters of our planet's history, from its molten beginnings to the formation of its first continents. But that's not all. Beneath the melting glaciers lie vast deposits of minerals, including rare earth elements essential for technologies like smartphones and wind turbines. Greenland has become a hotspot for mining companies racing to exploit these newfound riches. Scientists are also uncovering frozen ecosystems. Plants and microbes, perfectly preserved in ice for tens of thousands of years, are re-emerging. These remnants offer clues to how life adapted to past climate changes and could even hold potential for biotechnology. In Europe, the Alps have revealed astonishing artifacts like Ötzi the Iceman, a 5,300-year-old mummy found with tools and clothing. As glaciers retreat, more relics of human history come to light, reshaping our understanding of ancient cultures. Yet these discoveries come with a cost. Mining operations threaten to disturb pristine ecosystems, and rapid exposure to air can degrade artifacts and fossils. Scientists and policymakers face tough questions. How do we balance exploration, conservation, and exploitation? Similar processes are occurring in Antarctica, though there are some notable differences compared to the Arctic. As ice sheets in Antarctica melt due to climate change, they expose previously hidden geological features and materials. Ancient rocks and meteorites. Antarctica's ice sheet has preserved meteorites and some of Earth's oldest rocks, providing valuable insights into planetary formation and evolution. Fossil discoveries. Fossils of ancient forests, dinosaurs, and early marine life have been uncovered beneath retreating ice, revealing Antarctica's warmer, forested past millions of years ago. Antarctica is believed to contain significant deposits of valuable resources like coal, iron ore, and potentially oil and natural gas. However, under the Antarctic Treaty System, mining is currently prohibited to preserve the continent for scientific research and environmental protection. Melting Antarctic ice has also revealed ancient microbial ecosystems preserved for thousands of years. These microbes could provide clues about life in extreme environments and potential analogs for extraterrestrial life. The primary culprit? Human-induced climate change. Rising levels of carbon dioxide and other greenhouse gases have caused global temperatures to increase by 1.2 degrees Celsius since the Industrial Revolution. Warmer air melts glaciers from above, while rising ocean temperatures erode them from below, creating a double threat. While the outlook seems bleak, there's hope. Transitioning to renewable energy, reforestation, and reducing emissions can slow the pace of glacier melt. International agreements like the Paris Accord aim to limit global warming to 1.5 degrees Celsius, but action is needed now. Even small actions like conserving energy or advocating for sustainable policies can contribute to the larger fight. The glaciers are more than ice. They're storytellers of Earth's past and guardians of its future. As they fade, they leave us with a choice. Will we act to protect what remains, or let these icy giants become mere memories? Fascinated by Earth's changing landscapes? Like, subscribe and join us on this journey to uncover more stories of our planet.